Hi, so in this video, I will be discussing the pre-lab for experiments 8 and 9, which focuses on the two instrumentations involving chromatography. So just a reminder that this video, as well as the slides, are protected under the country's copyright law. So you're not allowed to reproduce or communicate the materials in any form without the permission of your instructor or from the Institute of Chemistry. Okay, so as I said earlier, the experiments 8 and 9 focuses on chromatographic methods. And these chromatographic methods are another branch of separation methods. There are other separation methods besides chromatography. So you've encountered this back in your Gen Chem lab classes. So precipitation and filtration are the basic ways of separating compounds depending on the differences of their solubilities and their um, phases. So separating a solid from a liquid. So distillation, so you've also discussed this back in Chem 16.1. So in distillation, you are separating your compounds based on the differences of their volatilities. So chromatography is another type of or another way of separating your compounds. So this time, chromatography separates your compounds depending on their interaction with the stationary phase. So you've already encountered chromatography back in Chem 16.1 and as well as in Chem 101.1. So chromatography, as a short recap from your previous Chem lab classes, so it is a separation method based on the interaction of your components or solutes with the stationary and mobile phase. So we can classify your chromatographies based on the type of column. So the form of the column. So if it is planar, so it is a planar chromatography. So examples of your planar chromatography are paper chromatography and thin layer chromatography. Whereas the other form of column is what we call a column. So it's like a burette or a test tube that has a stopcock. So examples of your column chromatography are gravity chromatography. So for Chem 101.2, we will be focusing on the instrumentation that involves the basic principles of chromatography. In particular, we will focus on gas chromatography and liquid chromatography, or HPLC in particular. So for experiment 8, so we will be using gas chromatography to determine the concentration of ethanol in alcoholic beverages. So gas chromatography, so it's similar to distillation in such a way that the separation of compounds is based on the differences of your compounds or the components volatilities. So the instrument for a gas chromatography is what we call a gas chromatograph. Okay, so this is a typical block diagram or schematic of a gas chromatogram. So you have your carrier gas, a flow controller, so to control the amount of gas flow going to your column. Then you have your injection port wherein you introduce your samples, the column. So in the column, this is where the separation between your components happen, and then the detector. So once the separated compounds reach your detector, so it is recorded into the computer and the electronics of the computer. So in gas chromatography, so we will obtain a chromatogram. So this is a plot of the instrument signal, or in this case, we're not really looking at the signal of the gas chromatograph, but rather the response of the detector versus the time at which it was detected. A particular compound is detected. So you will obtain two different informations from the chromatogram. So you have your retention time. So this is the time wherein your component elutes from the gas chromatograph system, or when it was detected by your detector. Okay? So this retention time will give you your qualitative information about the compounds. Whereas your peak area, so the area under the curve or the peak in your chromatogram, or in case the peaks are very narrow, so for example, the ones here in peaks 1 and 2, so they have very narrow peaks, so you will obtain the peak height. So both peak area or the peak height would give you your quantitative information. So how much is the concentration of your components in the solution. Okay, so for us to use the gas chromatograph, so you need to introduce your sample into the system. So you can introduce your sample by either manually injecting it using a syringe. So you will inject your sample through the injection port, or is your gas chromatograph is fully automated, so there is already an auto sampler, and the auto sampler will do the rest for you. So you just need to prepare your samples and then place it in the auto sampler. Okay, so some GC instruments, so they have an auto sampler which we call a carousel. So umiikot tong carousel, and then the auto sampler will obtain your samples. So meron din siyang injection dito. May syringe. So it is important to know what type of injection technique you will use when performing a gas chromatography analysis. Okay, so there are many types of injection techniques. So you have your splitless injection, thermal desorption, headspace, and solid phase microextraction. So in order for you to know what type of injection technique you're going to use, so you need to know what sample you are going to analyze. So since our sample in this experiment is alcoholic beverage, an alcoholic beverage. So our sample is a liquid. Okay? So you could either use a split or splitless injection if you will perform a manual injection. However, if um, you will use an automated GC, so you could just prepare your sample and then place it in a vial. Then the autosampler, which will use headspace injection, so automatic na makukuha yung sample from your um ay from the sample solution in the vial. So if you're going to use headspace injection, so basically in headspace injection, you are analyzing volatile organic compounds. So since ethanol, which is present in alcoholic beverages, is a volatile organic compound, so you can use headspace injection to introduce it into the gas chromatograph. So in the headspace injection, so you just need to place your liquid or solid sample in a vial, in a sealed vial, and then it will be heated up to some certain temperature, and then the vapor phase. So there will be an equilibrium between your sample and the vapor phase. So the injection, the syringe would puncture through the septum of your vial and would obtain the sample from the vapor phase. So not really from the liquid phase. Okay? So what will be obtained is the vapor, which is what you want to analyze in your gas chromatograph. So this is example of an headspace autosampler. So this was taken a long time ago, 2015. So before there was an autosampler, headspace autosampler for the GC at the ASL. However, recently it's not working anymore. So ginagawa na lang sa ASL is they perform manual injection when performing gas chromatography analysis. Okay. So there is another GC at the ASL which is under the laboratory of Dr. Gregorio. So yun naman yung GC na yun, ano naman siya, automated. So autosampler na yung ginagamit. And headspace injection yung ginagamit. So you just need to prepare your samples and then ipo-program na lang siya doon sa computer. So another factor that you need to determine when you perform a GC analysis is the oven temperature. So you could either perform an isothermal run, which means you are performing your analysis as constant temperature, or you could perform temperature programming. So that means that while you run your analysis, so you constantly change the temperature. So you constantly increase it. Okay, so if you will look at the chromatograms obtained at the different oven temperature programs, so mas maganda yung nakukuha na peak sa temperature programming. Okay, so this is an example of how temperature programming is used when performing JC analysis. So usually you start at a very low temperature, so at room temp, and then you gradually increase it. Then at a certain point, so after you've run your analysis, so you will slowly decrease the temperature of your oven back to the initial temperature or to room temperature. So para hindi masira yung oven pati yung column. So in this experiment, so you will construct a calibration curve that involves the use of internal standards. So before, you've already encountered the external calibration curve and the standard addition curve. So this time, you will encounter another type of calibration curve. So that is one that involves the internal standards. Okay? And from that calibration curve, So you would be able to quantify the amount of ethanol in commercial alcoholic beverages. So these are just the steps for the solution preparation. So from the stock solutions, so you will prepare the different calibrations standard solutions. So 9 calibration standards. So in the calibration standards, you will already include a standard of your analyte, which is ethanol. And for this particular experiment, so we will use acetonitrile as the internal standard. So it is important that you store these solutions in a well-fitted and airtight container, and that it should be protected from light and high temperature. So take note that we want to analyze ethanol in your sample. Okay? So dapat yung calibration standards nyo which contains ethanol, so dapat well-contained din siya doon sa container or sa kung ano man yung lalagyan mong solution for analysis. So for the instrument, so again, merong dalawang GC that is available sa ASL. So yung luma doon, which is used by the ASL, is the Shimatsu GC14B. And for this particular experiment, so you could use either of the two columns, so equity 5 or SPB 1000. So both of these columns use fused silica as the material. So the carrier gas that will be used is nitrogen gas. So you use an inert gas as your carrier gas. And the detector is flame ionization detector. Okay, so take note that the column for a gas chromatograph is usually very thin and coiled like this. So kaya minsan ang tawag sa ganito ay capillary columns because manipis lang yung column sa gas chromatograph. So later in the discussion, so you will see that magkaiba talaga yung columns that are used for GC and for an HPLC system. Okay, so for GC experiments, so again, you usually have carrier gas. So for this experiment, ang gagamitan natin, lagay sa lab manual is that you will use nitrogen gas as the carrier gas. So after preparing the instrument, you can now program it. So how you will operate the GC. So the nitrogen gas should flow at 1 ml per minute. And then itong program ng oven, so this will just be input in the gas chromatograph. Okay, so meron doon parang control panel sa gas chromatograph. So you will just need to program it there. Okay? So another important thing when you perform a GC analysis is you need to determine the temperature of your injector and the detector. Okay? So, bakit important na mataas yung temperature ng injector niya, yung injector port? Tapos, bakit mas mataas yung temperature ng detector kaysa doon sa temperature ng injector? Okay? So, in this particular experiment, the injection volume is 1 microliter. So in the next slide, so I will show paano madedetermine na exactly 1 microliter lang yung papasok sa gas chromatograph system niya. Okay? So there is a more detailed explanation for how you can use and operate the GC. So GC to So the GC instrument in the experiment module. So very comprehensive yung steps ng pag-operate ng GC na nakalagay doon sa experiment module. So after you program the gas chromatograph, so you can now use it to analyze your calibration solutions and the sample solutions. Okay? So first thing is that you need to run your calibration. So for you to determine the peaks for your calibration standards, so which peak is for the ethanol and which is for the internal standard. So typically you generate first a chromatogram with equal volumes of the analyte and the internal standard. Okay. Then afterwards, so you can already run your calibration standards. So for the sample preparation, so in a 1 ml cap sample vial, so you need to mix 0.50 ml of the sample. So this is a distilled spirit. So for example, vodka, which contains high concentrations of ethanol. And then you add a large amount of your internal standard. So bakit important na meron kayong malaking amount ng internal standard together with your sample? Okay, so you need to explain that in your ETQ. Okay, so after preparing your sample solution, so you could now inject it into your GC system using a suitable syringe. So kung manual injection yung gagawin nyo, you will use a syringe. However, kung automated naman yung instrument, so you will just use the headspace. So you just need to prepare your sample solution kung automated naman yung GC instrument. So after performing the analysis, so for the instrument shutdown, so you need to cool the instrument back to room temperature before you turn it off. So for this experiment, so you've encountered a new calibration curve, so which uses an internal standard. So an internal standard, so this is a known substance that is not present in yours. So that is one of the reasons why acetonitrile was used, because you usually don't find acetonitrile in alcoholic beverages. Okay? So internal standards are also added, particularly kapag GC analysis yung ginagawa, because there are errors that can be attributed to sample injections and the variability of the instrument condition. So mahirap kontrolin yung temperature and other conditions ng GC instrument. Okay, so that's why it's okay kung gagamit ka ng internal standard. So for a calibration curve that involves an internal standard, so the calibration curve is a plot of the ratio of your peak areas or peak heights against the ratio of the concentrations. Okay? So you have here sa Y value, so you have the ratio of your peak corresponding to the analyte or the sample standard, and then all over the peak area that corresponds to your internal standard. And for the X value, so you have the concentration of your analyte or the sample standard, and all over the concentration of your internal standard. So for the data treatment, so of course, you first need to obtain your calibration curve. And take note that for this experiment, so your analyte, so the analyte is ethanol. Your internal standard is acetonitrile. So you obtain the peak area ratio for the samples. So from the instrument, so you will obtain the peak areas or peak heights for the two components. Then you take the peak area ratio. And then after that, so you can solve for the ratio of the concentrations. Then after that, so to be obtain the calibration curve, so you just multiply the concentration of your added internal standard for you to obtain the concentration of your analyte in the unknown sample solution. Okay, so this is a sample chromatogram. So take note that the retention times in a gas chromatograph experiment is not really absolute. So pwedeng namumove siya, pwedeng mas late siya nag-i-elute, but relatively so una dapat na mag-elute si ethanol than acetonitrile because ethanol is much more volatile compared to acetonitrile. So for sample here, so you have ethanol approximately has retention time of 3.8 minutes. And acetonitrile has a retention time of 4.5 minutes. So these are the data for the calibration curve. So although in the experiment module, so na-solve na kasi yung calibration curve. So try to work on the calibration curve on your own and then check if you will obtain the same values found in the experiment module. So after obtaining your calibration curve, so you can now use it for your sample. Then you can determine the concentration of ethanol in your alcoholic beverage. That's it for experiment 8. So for experiment 9, so this time we will now use the other type of chromatographic instrumentation, so HPLC. So in HPLC, for this experiment, so you will be analyzing the concentration of caffeine in energy drinks and coffee. So HPLC works similarly to the gas chromatograph. So the only difference is that this time, your sample is a liquid. Thus, so therefore, dapat iba na rin yung magiging mobile phase. Okay, so yung mobile phase kanina sa gas chromatograph is a carrier gas. So dito sa HPLC, mas magandang tawagin na term is mobile phase. Okay, so which is usually a solvent or a mixture of solvents. Okay. So in the HPLC, so the mobile phase, so the solvents is delivered by a pump and it moves at a uniform rate and at very high pressures throughout your system. So that is one reason why sometimes yung HPLC it is called high pressure liquid chromatography. So due to this high pressure that is moving in your column, so mas mabilis yung pag-separate ng components nyo compared if you will use a gravity liquid chromatography. Okay. So same with your gas chromatograph. You will also obtain a chromatogram from your HPLC. Okay. So ganun din yung makukuha yung info. So you will obtain your retention times and the peak area or peak height. So this is a diagram for a typical HPLC. So you have here your mobile phase, so yung mga solvents. Then you have pump, which controls how much of particular solvent or mixture of solvents is used. You have here your sample injection port. And for ano pala to? For priming, so for preparing on draining your column. Then you have here your injection port. Okay? So yung injection port, mas malapit siya doon sa column. So this is a much more simplified block diagram for an HPLC instrument. So again, you have your mobile phase, so the solvents. So you have your solvent reservoir, where you have your different solvents. Okay? Then it will be pumped to the column by this pump. Then you have your loop injector. Okay, so where you will introduce your sample. So after that, so you have your column. Okay, so some HPLC systems, so they include what we call a guard column. Okay, so this is a type of column that is used to protect. So kaya guard column. So it's used to protect the much more expensive analytical column. So we usually separate the components you want to separate in your sample. And then, of course, you have your detector. Then the detector, so the detector is connected to a computer. So you could classify your HPLC method either as a preparative HPLC or analytical HPLC. So in an analytical HPLC method, so you just separate the compounds for the purposes of detection and quantification. However, so you could also use preparative HPLC. So that means that you are just using the HPLC to separate the different components of a mixture. Okay? So in the preparative HPLC, so you are determining the identities and the quantities as well of each component of your mixture. And then afterwards, it is collected to a fraction collector. Okay? So for our experiment, so we're not really going to use the caffeine in your samples further. Okay, so itong preparative HPLC, usually, kaya kinokollect pa yung analyte nyo dahil kasi meron pang subsequent na analysis na gagawin. Okay, so usually pang ano to, mga method development. Okay? So analytical HPLC, this is usually for quantitative analysis. So besides the analytical and preparative HPLC, you could also classify your HPLC depending on the mode that will occur during your analysis. So you have your absorption chromatography, partition chromatography, ion exchange chromatography, size exclusion chromatography, and affinity chromatography. But for Chem 101.2, so we will focus on partition chromatography. Okay? So from the word itself, so you are just using the HPLC to partition or to separate the different compounds depending on their interaction with the stationary phase and the mobile phase. Okay? So itong iba pang types ng LC, so ion exchange, size exclusion, so you will encounter that when you get to your biochem lab. So sa Chem 145.1. So mas ginagamit siya for separation of biochemical, biocompounds, proteins, DNA. Okay. So for the partition liquid chromatography, so you could classify it further depending on the type of your stationary phase. So you have your normal phase mode, your reverse phase mode. Okay? So katulad lang to nung tutunan nyo back in Chem 16.1. So for a normal phase, usually your stationary phase has a high polarity. So these are polar, polar columns. Okay? And dapat yung mobile phase, which are your solvents, so least mas mababa yung polarity niya compared to your stationary phase. Okay? Pag reverse phase naman, so this time your stationary phase, so the column is non-polar. Okay? So for you to easily remember which stationary phase is used for a normal phase LC, so you could use the following mnemonic. So NPSP. So a normal phase chromatography has a stationary phase which is polar. Okay? So NP normal phase, S is stationary, then P is polar. Okay? So kapag na-memorize nyo yan na the normal stationary phase for a normal phase is always polar. So connect nyo na rin na pag reverse phase, so non-polar naman yung stationary phase. So now let's look at how you introduce your sample into an HPLC. So similar to the GC, so you could also introduce your sample to your HPLC system manually or automated. So may auto sampler. So for the HPLC, so medyo complicated ng onte yung manual injection. Okay? So in HPLC systems, you have your loop injector. So bakit merong loop injector? So if you will recall, so in our introduction to the HPLC, so the movement of your solvents, so the mobile phase, occurs at high pressures. Okay? So mahirap na mag-inject kayo ng sample into your HPLC na merong malakas na pressure na nangyayari. Okay? So kaya na-develop itong loop injector para hindi masisira yung column pag nag-introduce kayo ng sample to your system. Okay, tapos mape-preserve yung high pressures. Okay. So for the loop injector, so we usually have two positions. So you have your load position and the inject position. So again, sa pump nyo, which is connected to your mobile phase reservoir, so it is being, the mobile phase moves through the pump going to the column at high pressures. Okay? So mahirap mag-introduce ng sample ng mataas yung pressures. Okay? So kaya merong loop which separates your injector from the column. Okay? So the first thing that you do when you inject your sample is to place it into the load position. So usually ito yung right. So may parang knob yun sa ganito siya. So may knob yung loop injector nyo. So you place it on the load position. So nasa right. Okay. So what happens is that if you inject your solution using a syringe, so yung sample nyo, papasok siya dito sa fixed volume sample loop. So for example, kung ang kailangan nyo lang i-inject sa HPLC ay 1 microliter, so meron ditong 1 microliter na sample loop. So kapag sobra yung na-inject nyo, so the excess will go out of the sample loop. So pupunta lang siya sa waste bin. Okay, tapos yung 1 microliter, so mare-retain siya dito sa loop. Okay? Then after that, so after you inject it, so babalik nyo naman yung knob into the right position at to the left position. So to the inject position. So this time, so kung ano yung na-retain na volume, so for yung example natin kanina, 1 microliter. So merong 1 microliters of your sample that is already in this sample loop. So pag tinurn nyo na siya into the inject position, makakonect na yung pump ng solvents nyo to the sample loop. So mapupush na siya ng mobile phase ng solvents going to your column. Okay? So again, kaya merong loop injector. So that is due to the high pressures that is used in your HPLC system. So again, meron ding auto-sampler for your HPLC. So dito, you just need to prepare your sample. So kung sa GC, meron kayong programming for your oven. So sa HPLC naman, so you can determine the composition of your mobile phase. Okay? You could either use an isocratic mode or a gradient mode. Okay? So in the isocratic mode, so you have a constant composition of your mobile phase. So fixed siya all throughout your analysis. Whereas in your gradient mode, so as you perform your analysis, so nagva-vary. So merong certain solvent na nag-i-increase, and then there is also another solvent that decreases. Okay? So usually itong gradient na mode of elution, so usually ginagamit to kapag method development. When you want to determine what type of, kung ano yung magandang mixture for the mobile phase. Okay? So isocratic, so usually ginagamit yan kapag mas gusto nilang ma-obtain yung mabilis na analysis or quantitation of your samples. So for this experiment, so we will be using the HPLC, so again, to determine the concentrations of caffeine in energy drinks and So your caffeine is a non-polar. Okay, so for the sample preparation, so again, you need to prepare a stock solution and then standard solutions. So these standard solutions should be filtered prior to the. For the sample solutions naman, so your samples would be either an energy drink or coffee. Okay? So you need to dissolve the, so kung coffee yon, so you need to dissolve it with the appropriate amount of distilled deionized water. And then afterwards, so you need to sonicate it at maximum power for 5 minutes. So again, ang purpose ng sonication is to ensure na homogeneous yung sample niyo. Okay? Then after sonicating your samples, so you can now filter it using a syringe filter. Okay, so important dito sa HPLC na lahat ng solutions na i-inject nyo, pati yung mga mobile phase, so lahat sila na filter. So bakit kailangan na-filter sila? So that is to prevent the blockage of your column. Okay, so para hindi magkabara sa column nyo. Okay? Kasi pag nagkaroon yun ng bara, so mas madaling masisira yung column nyo. So, if you will perform a manual injection, so ito yung gagamitin na sample injection syringe. Okay, so medyo mahaba yung needle for the syringe. Okay. Then you also have this other syringe. So this is used for filtrating your standards and samples. Okay. So usually meron pa ditong parang septum which contains your filter paper. Okay, so Wattman filter paper. For the mobile phase, since masyadong marami yung mga solvent na ginagamit for mobile phase, so usually perform vacuum filtration. And you degas it using sonication as well before you place it into the solvent reservoir. So yung mga solvent na ginagamit for HPLC, these are usually HPLC grade. So hindi basta-basta na kahit na anong solvent yung ginagamit sa HPLC. So meron solvent grade din, which is particularly used for HPLC analysis. So the instrument for this experiment, so you have your sa ASL, so you have your Shimadzu LC10 AS liquid chromatograph, which has a UV vis detector and a manual injection system. And the column, which is a C18 column. Okay. So since C18 yung column nyo, what type of partition LC would occur here? So C18 is a non-polar compound. So therefore, this analysis is a reverse phase HPLC. Take note na yung sample kasi natin, the analyte is also a non-polar compound. Okay. So this is the HPLC system at the ASL. So you have here your solvent phase reservoir, mga container ng mga solvents. So usually naka-place sila in amber bottles. Then you have your pumps here. So sa pumps, nangyayari dito yung what we call the bridging. Okay, so before you perform your analysis, so pinipurge muna yung column. Okay, so pine-prepare siya para matanggal yung mga impurities, pati yung mga um, compounds, mga analytes na naipon doon sa previous analysis or previous na paggamit ng HPLC. Okay, so medyo matagal yung pag-purge na yun. Okay. Then you have your loop injection, loop injector port. Okay, so manual injection to, walang auto samplers sa HPLC ng ESL. Then inside this, so nandoon yung, so meron dito sa loop injector port, may nakakonect yan na fixed sample loop, and that is connected to the column. Okay, so nakakonect siya sa column, then may oven din sa loob ng column. So the column is then connected to your detector. Okay. Tapos yung detector, so connected na yan sa computer, okay, where you will obtain your samples. If I remember correctly, yung ginagamit sa ASL na pang-collect ng data is an integrator. Okay, so medyo luma na siya. Hindi siya yung modern computer. So integrator, so parang pinaplot niya yung chromatogram. Okay, tapos manual nyo siyang i-measure. So, kailangan nyo ng calculus para ma-measure yung mga old manual computations to determine the area under the curve. Okay. Tapos meron din ditong fraction collector. So kung gagamitin nyo yung HPLC for preparation and for subsequent analysis. So kukollect yung analyte. Okay. Again, sa experiment natin, we're not really going to collect your analytes. Okay. So these are examples of some HPLC columns. Okay, so kung maalala nyo kanina yung sa GC, so different sila. Okay. So, sa GC, naka-round off, naka-coil sila, tapos manipis yung column. For the HPLC, so medyo makapal siya, tapos mahaba. Okay. So nakapack dito sa loob yung inyong stationary. Okay. Tapos, yan pala, important sa HPLC na tama yung connection ng column from the injector port, pati doon sa pump, then going to the detector. Okay, kasi masisira yung column nyo kapag mali yung flow ng mobile phase sa loob. Okay, kaya merong arrow. Okay, so that indicates the flow of the mobile phase. So going from the pump and the injector port, going to your detector. Okay. So the conditions for the instrument operation, so the mobile phase that will be used is a 50 to 50 water to methanol. And since ang detector natin ay UVV, so you need to program as well the wavelength at which you will detect your analyte. So yung caffeine, so it has a lambda max of around 278 nanometers. So dapat you need to set the lambda max of your detector to that. Okay. So after you program the LC instrument, you can now run your blank calibration standards as well as the sample, so using manual injection. And then from those runs, so you will obtain your chromatograms. And from those chromatograms, so you could already obtain your retention times as well as the peak areas for your. So this is a sample chromatogram obtained for caffeine at 50 to 50 water methanol mobile phase. So dito sa journal na to, so ang nakuha nilang retention time for caffeine is around 2.5 minutes. So these are the data for the data treatment. So again, first you need to construct your calibration curves. So this time wala naman na tayong internal standard. Okay, so it's just your analyte. So plot the concentrations of your standards. So external standards and the peak area or peak height. Okay. So itong peak area, these are unitlets. So arbitrary lang yung units. So after constructing your calibration curve, so you could now use the calibration curve to determine the concentration of your analyte in the sample. So again, yung data na to, so try to do it on your own and then check the experiment module if you obtain the same. Okay? So paano kung halimbawa yung sample nyo masyadong mataas yung peak area? So lampas na siya dito sa peak area nung highest calibration standard nyo. So what you could do is you can dilute your sample. So just take note of the dilution factor and then run it again through the HPLC. So dapat yung peak area, yung response ng instrument nyo should be within the range of your calibration curve. Okay. Tapos kung ano yung makuha yung peak area doon, so just multiply it with the corresponding dilution factor. Okay. Kung mababa naman siya dito sa lower limit ng calibration curve nyo, so what you could do is to add more standard. So mas mababa pa dito sa 10 ppm. So you also should include a blank. Okay, para pwede siyang from zero as well. Okay. Okay, so that's it for this pre-lab discussion. So if you have any questions, so just message me through this